Thinking about the two intercept form, this implies the following. How are we going to derive these from a specific graph where we have our particular y-axis and our x-axis, and take note that you're given a line. I'm not going to do the line that is actually having a positive slope, but rather let's switch it around. Let's go with the negative slope version where we have this happening. And so what we need to recognize first is the following. Hey, we have two intercepts. Yes, indeed, it is noticed on this particular graph. Do you know where it is? Yes, you should, which is the one on the y and the one on the x, which is what we see right here, where the blue line touches the y and the x-axis. So the one that we're going to highlight first is, moving from left to right, the y-axis, which is highlighted as 0 and b. That is the point that we are going to highlight first. And the other point here is the where it is touching the x-axis, which we're going to highlight as a some number, but take note that the y of that particular value for x is 0. Now, once we have this, we're going to move on to the next step, which is to address another variable to consider. And the variable to consider is the slope. And to highlight the slope, we do recognize that the slope is the relationship between the change in y and the change in x, which is expressed as m. And so m here is equal to change in y, which is y minus y naught divided by rx minus x naught. Now, how are these reflected on these 2 points? It doesn't matter here, but what we're going to do instead is to go with our left to right, starting with left, which is the point where the y-axis is actually intersecting our blue line, and this here is highlighted as our x naught, y naught, and on the other hand we have the other point, which is our x and y. So once we have this addressed, we can then represent our a0 and our 0b in our slope form. Therefore, we have these to be expressed as 0 minus b divided by our a minus 0. This is equal to negative b over a, and this is indicating our slope for this line, which demands the use of the y and the x-intercept. Now, our next step is from our point slope form, which we talked about on our previous video. So I encourage you to check that out, and remember that we derive this, and this is represented as y minus y naught equals to m all multiplied by our x minus x naught. Now, this we are going to address it based off of our determined slope and picking one point. And so our determined slope, remember, is negative b over a, and this is multiplied by any point that we pick. So we're going to pick a point. In this case, we're going to pick our y-intercept. It doesn't matter. You can pick a y-intercept, you can pick your x-intercept point. What matters is that you are still going to get the same answer. So in this particular case, I will encourage you to try it out. I tried the y-intercept. Next one you should do as a challenge is to try the x-intercept and see whether you arrive at the same equation as I'm about to derive. So what we have for our y remains the same, but our y naught is going to be, in this case, b. And so on the other hand, we have our x to be not given, we're just going to put it that way, and our specific x naught is addressed as 0. So we're going to do minus 0 as shown right here. And so once we're able to address this, we can then evaluate this particular equation, and to do that, what we have to do is to do the following first. First is to be able to address the one in the bracket with a 0 x minus 0, which gives you, of course, x, and therefore we have our equation, which is on the right side, negative b over a all multiplied by x. We have y minus b, which says as y minus b. Now I'll add b to both sides. Therefore, we have our y to be equal to minus b over a multiplied by x plus b. And so once you're able to arrive at this, our next step is to do the following. Hey, we see that there are common variables that are here, and the common variable here is b and of course negative sign. So we're going to factor out our negative b, and this is going to result in the following. Here we have y is equal to negative b all multiplied by what? X over a. Take note that we are taking a negative sign here and it becomes now negative. So here will be negative and this is going to be 1. So once we have this, we are going to move on to the next step, which is to divide both sides by negative b so as to move our negative b to the other side of the equal sign, and therefore we have the following. Y over negative b is equal to x over a minus 1. And then our next step is to do the following. Since we have our y and x and they are fractions, we are going to put them on one side, and the constant, we're going to move it to the other side, and what that results in is rearranging shows us that yes, we do have 1 to be equal to x over a plus y over b, and this is the equation that we are looking for, which is called the two intercept form. And this two intercept form shows you the following: that the denominator of your x variable is the a, which is the x on our graph where our blue line touches the x-axis, and on the other hand we have our y over b where our b is where our blue line touches the y-axis. And so this is pretty cool to see how this is addressed using the two intercept form from our specific graph, which is shown right here. Various conditions to remember, but it's really fantastic to see how this is derived by picking any point, and by now you should be able to see that whichever point you choose in this step, you will still get the same outcome, which is shown right here. All the same, truly appreciate this. Please hit a comment down below, let me hear your thoughts. By that way I can talk to you all soon. Stay smart as always and believe in yourselves.